So we're getting to the next part, which is reference types. So the first thing about reference types is we're talking about data storage locations. So in Solidity or in the EVM in general, so variables are declared with the words storage, memory, or core data to specify location to save the data. Storage variable is a state variable stored on the blockchain. Memory variable are variables that store in memory and only exist while the function is running. We have a couple examples just below. And code data is a special data storage containing data passed to the functions while you calling the functions. Let's take a look at an example just below. We have a UN256 array. We will talk about array just below. That is named ARR array. This array is stored in storage locations in the virtual environment. Then you have memory, which is just right below. Is you can have something like a function G, where it takes in a like another array, like a UN256 array, and then it will return something else, right? This one will be stored inside the memory as you process, as the function is being processed, and then it clears away, right? So this only exists while the function is running. And you also have code data. Code data, for example, in function H, you have a UN256 array that's passed in code data instead of memory. That means this code data will persist. This code data will persist even after the functions stops. And you can find, if you go to the transactions that's interact with these functions, you see the code data just below. So you see what is being passed in, and this code data will persist. Right? And lastly, for reference type, we have struct. We mentioned struct before, but this one we're going to go a little bit deeper into struct. So struct is a data format that programmers declare to gather many variables of different formats under one name for easy use in contract, right? For example, we have a contracts right here called to-dos. So, things that I'm supposed to do. And you can have a struct called to-do, which includes essentially two different variables inside. One is a variable called text, and that's a string. And it's a variable called completed, and it's a boolean, right? And then next thing you can do is something like initialize an array of to-do structs. So think about a list of objects, right? That has the shape of to-do, has like the type, right? And it's called to-dos in this case. And then what you can do, you can create, right? You have a function create, and what you can do is you input a string in code data, so you're passing the information in the transactions, in the code data part of the transaction, sending to the function, and it has a bunch of text, right? String, code data, text. So code data here is just where you're saving the the information. And three ways to initialize a struct is you can call it like a function, to-dos, in this case to-dos, because it's an array here. So you can push. So because if you look in here, to-dos here is an array, right? Because you have an array of to-do. And then because it's an array, what you can do is you push into it. And what do you push in this case? Right? You push to-do into the array because array is similar type. So you push to-do and you initialize it like a function. So you have something like this: to-do, text, and false. So what does it mean here? So you recall to-do has a variable called text, and it's a string, right? So basically what I'm passing in called data, this is temporary variable. So the code data I'm passing in will be initialized into the struct, into the variable text in this struct with using the content over here. And the value of the complete variable will be false, right? So this is how you initialize an array. You initialize a struct. You can also do is something like key value mapping, which is more clear rather than this one. This one, you're not 100% sure what is, well, you know the order of it, so you kind of infer from it, but you want to be extra extra careful and be explicit on what you want to declare. You can do something like this, which is you have to do, and you have text, which is this, map it with the text, the value you want to add in, complete here, and also the value false. You can also initialize an empty struct, so like this, and update it like this, just like a JavaScript object. Very similar. And the complete will, in this case, todo.complete, which is the value of the variable complete inside this struct, is going to be false, which is a default value. And you can also, next thing you do, you can initialize, you add, add information in. You can also push inside the array. Solidity automatically create a getter for to-dos, and you don't need this functions, you don't need this get. So if you use public inside your, when you declare a variable and you have public, it will automatically create a getter functions. However, you don't need to create this function. However, it's a good thing for you to create this function, because then you can be fairly explicit on how the getter function should look like, and oftentimes it's more clear than using public. You can also update text. You can have something like this to update the text inside the struct, and something like this would be to do storage, and then you select the index, and then you update that based on that. Right. So this is like essentially what you're trying to do is you pass the information in here and also the index, and inside your array of to-dos, you select the index of the struct that you want to change, and then you go this line, you change it. And similarly for this one, this one's for changing the completed value.